Hey, we're going to use logs to solve equations this week, and if you did the work from last week or if you were a little bit confused, here's one thing I want you guys to remember. We learned about, this is all very abstract in the beginning, and I'll do a couple quick examples, and then I'll do some more examples to help you out. But essentially, we learned about logs before we left for break, and logs are, in a way, like the opposite or the inverse of an exponent. When your exponent's unknown, you can use a log to figure out what that exponent is. And so from last week's work, if we had something log base a of b equals to m, the exponential form would be, this is the base, so that a to the m would equal b, where this is the exponent, this is the base, and this is what it's supposed to equal. Now the way we use that is anytime our unknown is in the exponent, we're going to switch to the log form, and anytime our unknown is in the log, we're going to switch to the exponential form. So if I was trying to solve something like this, I noticed right off the bat my unknown's up there in the x. That's not any good. To get it out of there, I have to switch to the log form. So I need to basically understand how where this a is and where this a is, where this b is and where this b is, and how this is the exponent and that's the exponent, and just flipping from one form to the other. So coming back to this whole idea and really understanding that when you look at an expression like this, we're saying this guy here is the base, this is the exponent, and this is what it's supposed to equal. And if I was teaching this to you guys face to face, I would probably stand up there literally for like 3 or 4 minutes saying, kids, listen, this is the base, this is the exponent, this is what it equals. This is the base, this is the exponent, this is what it equals. And I would just like say it, and I would tell you the story about Mr. Grady, who made us say it for 5 minutes, and it was super irritating, but it stuck with me. So when I have an expression like this, my unknown's up there in the x, I need to switch to the log form. So I'm going to go log, and then the base of my log is whatever this is. This is the base. The exponent that's here goes over here, and whatever it's supposed to equal, that goes here. And now I can bust out my calculator and get a decimal approximation for this value. Now if you did your test, you know that the next thing to do is to take log of 10 divided by log of 5 and get a decimal. But I'll go more into those descriptions and stuff in the other examples. Now, on the other hand, if my unknown's in the log, then I'm going to switch to exponential form. So I'm going to do kind of the same thing. This down here, this is the base, this is the exponent, and this is what it's supposed to equal. This is the base, right? That's the exponent, that's what it equals. So I'll change this to, that's the base, right? That's the exponent, this is what it equals. And so for this one, I could then just get my calculator out and take 3 to the 5th. It's a big number, I can't do it off the top of my head. But you're going to see me switch back and forth from log form to exponential form. It's a weird thing. There's really no making sense of it at this point. Like, it's not going to make sense. You just have to know to do it. And you have to know, and I'm going to say it again. Here I go, right? This is the base. This is the exponent. That's what it's supposed to equal. This is the base. That's the exponent. That's what's going to equal. Anytime your unknown's in the exponent, you're switching to log form. Anytime your unknown's in the log, you're switching to exponential form. If you can get that straightened out and just hunker down and do it, this is not a problem at all. We'll go through a few examples together, and there's a few other little tidbits I gotta say about, like, you know, when we use 10 as our base, or what happens if it's log with no base, or if it's ln, or what happens if there's an e. So do watch the next few examples, but you know, this is not too shabby. The answers are all going to be very large or very weird decimals, so don't be alarmed.